Hello, everyone. Let's take a look at this question today. Here, enter an adiabatic nozzle steadily at 600 kilopascal, 400 Kelvin, 150 meter per second, and leaves at 500 kilopascal, 200 meter per second. The inlet area of the nozzle is 1 meter square. Calculate the flow. Calculate and determine if the flow is isentropic. Compute and calculate the exit temperature of the air, that is the T2, and calculate the exit area of the nozzle. Now, let's assume we have the schematic given here today. Based on isotropic establishment, that is the constant isentropic process, we have all the parameter given, that is P1 given, T1, V1, P2, V2, and we have the area 1 inlet, and we have the isentropic compression, which is 1.4, and we have Cp, and we have the constant for gas, ID gas. Now, using the mass equation for the isentropic, we can deduce that rho V1 A1 equals rho V2 A2. Using the energies also, we can deduce that T1 equals V1 squared 2Cp equals 2 T2 V2 over 2Cp. And using the isentropic, we can also deduce that P2 over P1 equals T2 over T1, gamma over gamma negative 1, and also the state equation and the energy equation being given. Now, to find our T2 becomes this equation, that is T2 equals 1 V1 2 over 2. By slotting all the values, you can get T2 to be 391.29 Kelvin. Also, using the isentropic equation, P2 over T1 equals T2 over T1 gamma over gamma negative 1. We can deduce that the P2 equals P1 T2 over T1 gamma negative 1 by slotting all the values using the equation. We can deduce that P2 equals 55.02 Kelvin per Pascal. Therefore, by checking the isentropic check, the calculated 55.50 kilopascal is not equal to the given experimental 500 kilopascal. So therefore, the flow is not isentropic. Since it's not equal, the pressure is not equal, then it's not isentropic. Now, using the state equation, which is P1 over RG T1, we can find the density 1 from the inlet. Rho 1 equals P1 over RG T1. To slot in all the value, we can calculate the force density of the inlet equals 5.23. Also, we can find the exit density of the nozzle, which is P2 over RG2, which equals 5.50 over 287, 391.2. Don't let us forget, you need to multiply the pressure by 10 to 3 because it's in kilopascal. So our density becomes 4.95 kilogram per meter cube. Now, by using the mass equation based on the isentropic flow of the nozzle, we can deduce that M dot equals rho 1 V1 A1 equals rho 2 V2 A2. And this is very important equation. for constant mass flow rate due to the nozzle that is asymptotic. Therefore, our hem, our mass flow rate, which is constant, equals rho 1 v1 a1. By slotting out the value, we have 784.450 kilogram per second calculated. By finding to find the exit area of the nozzle, we can use the formula again. Then we have A2 equals m dot over rho 2 v2, and this gives us 784.505.52 times 200. Our A2 becomes 0.88 meters squared calculated. YT2 also equals 391 Kelvin. Thank you for staying tuned.